in measurements, and we said that every single measurement that you make is going to have some degree of uncertainty associated with it, and that is always going to be the very last digit. Right? Any measurement that you make, the last digit is always uncertain. Measured numbers which have uncertainty associated with them are very different than what are called exact numbers, right? And an exact number is one in which there is no uncertainty, right? That sounds like a double negative, which can sometimes be confusing. What an exact number is means exactly that. It is exact. And there are a couple ways by which we're going to encounter exact numbers. Numbers that we get from counting things. All right, so for example, if we counted how many students are in class, all right, and we saw that there's 34 students. Okay, there aren't 33.9 of you here. Even though some of us might think we didn't bring our whole selves today, there's an exact number, right? 34 is not 35, it's not 33, it's not 33 and a half. There's exactly 34 people. So when you count things, whether it's people, cookies, baseballs, whatever, that's an exact number. That's considered exact. There is no uncertainty. It means you're exactly certain, in other words. We also get exact numbers by comparing two units in the same measuring system. All right, so for instance, we may know that in a foot there are exactly 12 inches. There are 12.01, there's 11.99, there's exactly 12 inches in a foot. And then similarly, as we'll see in a little bit today, in the metric system, there's exactly 1,000 grams in 1 kilogram. All right, there isn't 1,000.01 or 999.99999. There's exactly 1,000. So these are two instances where we're going to encounter these exact numbers from counting things and from comparisons of units within the same measuring system. So we can think of when we encounter exact numbers and we start using them in calculations, they are not going to affect the number of sig figs in the calculation. In other words, you can think of them as having an unlimited number of sig figs. All right, so when we have to address sig figs in the calculation at the very end, we're not going to worry about those exact numbers. They're not going to tell us where to round, for instance. The measured numbers would, right, because there is uncertainty associated with those. All right, so again, we get exact numbers from counting things, and we also get exact numbers from equalities or comparisons of units within the same measuring system. So whether it's the metric system, or whether we're comparing units within the US system, those are going to be exact numbers. And there's a big difference between them. All right, let's take a look at the following. We're going to first of all identify them as exact or measured, and then if they are measured numbers, how many sig figs are in it. 3 coins, measured or exact? Look, in my pocket I have 3 coins. That's exact, right? I can count those coins. So unlimited sig figs for that one. We have a circle. The diameter is 7.902 centimeters. That would be, we can measure the diameter, all right? And based on our measuring device, we can estimate, in this case, to the thousandth place. So how many sig figs are in this? 4 sig figs, right? The non-zero digits are significant. The 0 here is trapped or sandwiched, so that makes it significant. So we have 4 sig figs. What about 60 minutes in an hour? Exact or measured? That would be an exact relationship made up of exact numbers, right? So that's exactly 60 minutes, not 59.9 0.9998 minutes in 1 hour. All right, so exact versus measured, we need to know the difference between them. And again, we can tell whether something is exact either by counting or whether it's a comparison of units within the same system. So what we went through at the end of class on Wednesday, and then what we sort of recapped today, determining how many sig figs we have in a measured number is the first step, and then using that information to do calculations and incorporating it into whether it's multiplication, addition, subtraction, division, etc. So that's going to be our goal here in this subsection of chapter 2, is to use that information, how many sig figs we have in our calculation. In order to do that, we have to first of all talk a little bit about how we round numbers. Right? So typically when you are doing a calculation and you stick your numbers into your calculator, sometimes you're going to see, maybe 10 or 11 digits in your answer. Well, what I would not like to see as your answer is those 10 or 11 digits, right? You have to make sense of that number and you have to round it to the correct number of sig figs. So rounding is going to be important. So let's take a look at some general rules for rounding. So if we're going to round and the first digit that we're going to drop is 4 or less, then that digit and all the following ones are going to be dropped from the number. If that first digit to be dropped is 5 or more, then that last digit that we're going to keep, we're going to increase by 1. All right, that's a lot of words, maybe a little confusing. Let's actually take a look at some examples of how we round. So here we have 8.4234, and we're going to round this first of all to 3 sig figs. So where are we going to start in our number in determining our sig figs? Are we going to start counting from the left side or from the right side? We're going to start from the left, right? So that's our first. That's our second, and the 2 here is the third sig fig. So we're going to go all the way to 2, and then we look at the next digit that comes after the 2. That's a 3, this one here, which is less than 5. So we're going to drop that and all the digits after it. So if we round that number to 3 sig figs, we end up with 8.42. If we look at 14.780, all right, again, we start at the left and we work our way across. So the 1 is our first, the 4 is the second, and the 7 is the third sig fig. We look at the next digit, which is the 8, and that 8 is more than 5, so we're going to add 1 to the 7. So we end up with 14.8, and then we drop the remaining digits. Right, so in this case, we're rounding that 7 up because the next digit is more than 5, or 5 or above. And then this third one, 3256, 3,256. So again, we start on the left side. So 3, 2, and 5. Those are our first 3 sig figs. We look at the next digit. That's a 6. That's 5 or above. So we add 1 to the 5. So we end up with 3, 2, 6. So will I round 3,256 as 326? No. So in a big number like this, what do you actually do to that one after you round it? You can't just drop this, all right? You have to replace it with a 0 to keep the fact that your original number here was a thousands, right? So we're going to replace that with a 0 at the end. So whether you have numbers that you're rounding that come after the decimal point, we're going to drop those. If they come before the decimal point here, we're going to use it to round, but then we're going to keep that place. We're going to keep that ones place as a 0. Right? When you round it, the final answer should make sense. Right? 3,256 doesn't round to 326. That doesn't make any sense. All right, so if you're going to round those to 2 sig figs, all right, we're just going to go through a couple of these. Let's take a look now. We'll do this one in green. Let's try that again. All right, so 2 sig figs here. We're going to go for the 8 and then the 4. All right, those are our first 2 sig figs. The 2 that comes after the 4 is less than 5, so this then would be 8.4. All right, and then the 14.780. The 1 and the 4 are the first 2 sig figs. The 7 that comes after the 4 is 5 or more, so we're going to add 1 to the 4 here, and that ends up being 15. And then what about the 3, 2, 5, 6? What would that be rounded to 2 sig figs? Raise your hand. I think you know that one. 3, 2, 5, 6. Is that half raised? What is that? Is that half raised? What do you think? 3,300? Was that a question mark at the end, or was that 3,300? Okay, so let's see. First and second. All right, what comes after the 2 is a 5 or above, so we're going to add 1 to that 2, so that's 3, 3. And then the remaining digits, we don't just ignore them, we have to keep those places, so we change them to zeros. So exactly right, 3,300, 3,300. So rounding is going to be important when we start looking at applying some of the rules when it comes to sig figs. All right, so knowing how many sig figs you have in a number and then being able to round properly are going to be the ammunition that we're going to use to approach or to tackle these particular problems. So when it comes to the rules for sig figs in mathematical operations, we're going to see 2 different rules. Okay, and it's important that you don't get them mixed up. So there's one rule that we use for multiplication and division, and then there's a second rule that we use for addition and subtraction. All right, so the rule for multiplication is the same rule for division, and it goes as follows. So when multiplying or dividing numbers, the answer can only have as many sig figs as the number with the least number of sig figs. So here we're looking at the numbers that we're multiplying or dividing. We're seeing how many sig figs are in those, and then when we stick everything into our calculator, the final answer that we get, we're going to round that to whichever number had the least number of sig figs. All right, so if you were to do this and you plug this into your calculator, first thing to realize is all we're doing here is multiplying and dividing. So we're going to use this rule. So you stick this into your calculator, and you can do this now if you have your calculator with you. Right, so if I gave you that on an exam, for instance, on a test or a quiz, and you stuck it in your calculator, and you wrote this here as your final answer, all right, I'm going to be very, very disappointed if you write all of those digits out, right? So it's going to be a little frowny face if you wrote this. You have to apply the rule for multiplication and division. So how many sig figs are here? 2. How many sig figs are here? 4. How many sig figs are here? 3. So your final answer then can only have 2 sig figs, right? With the number with the least number of sig figs. So 2 sig figs here, 4 sig figs on that one, and 3 sig figs. So we're going to round our final answer to 2 sig figs. So we're doing the same thing that we did before. Look at the first two digits here. The next one is less than 5, so we're going to keep that 4 as it is. So we end up with 5.4 rounded to 2 sig figs. All right, so the rule here is relatively straightforward. We just look at how many sig figs are in the thing or the numbers that we're multiplying and dividing. Okay, does that make sense? So in order to do this, you have to be able to determine how many sig figs you have in the number, right? Which is what we talked about the last time on Wednesday last week. All right. Sometimes something opposite to what you can expect may happen with your calculator. So in the previous example, we saw that your calculator spat out at you a bunch of digits, and you have to round it to the 2 sig figs. Sometimes your calculator is going to give you fewer sig figs than you should have in your final answer. So for instance, if you divided these two numbers, 8.00 divided by 2.00, your calculator gives you 4. Just 4. Right? You can confirm that with your own calculator. Well, this has 3 sig figs and this has 3 sig figs. So according to the rule, our final answer then should have how many sig figs? 3. Right? Your calculator is telling you that there's only 1 sig fig, but that's not what the rule is saying. We should have 3 sig figs. So how can we make 3 sig figs out of 1? We can add a couple zeros at the end to make it 3 sig figs. Right? Remember, when you have a 0 at the end of a number with a decimal point, those zeros are significant. Right? So we can add those, and you should, right? According to the rule here. This is telling us that we're dividing a number where we can estimate to the 100th place by another number that we can estimate to the 100th place. So our final answer there is going to have 3 sig figs in it. So and you're going to be doing lots of calculations, when you get your final answer from your calculator, you have to make a little bit more sense of it, right? Don't just celebrate that you get something. Think about the answer. Does it make sense? Does it conform to the rules that we talked about? All right. Let's have you do this one. 5 points. So take your calculators out if you didn't already. 5.00 centimeters times 3.408 centimeters divided by 2.0 centimeters equals. And I'm going to do it along with you with my calculator. See what I get. What does your calculator give you?
8.52.
8.52? So we multiply it and we divide it, right? So the rule was the answer can only have as many sig figs as the number with the least number of sig figs. How many sig figs in 5.00? How many sig figs in this one? And how many sig figs are in 2.0? So then this here, you have to round it to 2 sig figs. And then that would be 8.5 as your final answer. And then the unit here, if you pay close attention to it, is not just a number, but the unit as well, which would be centimeters. All right, so multiplication, division is the same rule, which is the answer can only have as many sig figs as the number with the least number of sig figs. The second rule that we're going to take a look at is a rule that we use for addition and subtraction. So it's the same rule for addition that we use for subtraction. And the rule goes as follows. When adding or subtracting answer can only have as many decimal places as the number with the least number of decimal places. All right, so here we're looking at how many places after the decimal point we have in the numbers that we're adding or subtracting. And it's different than multiplication division where we looked at the number of sig figs. I find that the best way to do this that makes it a little less foolproof, or more foolproof, or easier, I guess, not as challenging, is to rewrite the numbers and just line up your decimal points. That way you can visually see really quickly how many decimal places you have in each of the digits that you are adding or subtracting. All right, so for example, if you added together these three numbers, 2.012 plus 61.09 plus 3.0, right, your calculator is going to spit out at you 66.102. Which number has the least number of decimal places? The first, the middle, the top, the middle, or the bottom one? The bottom one, right? This has one decimal place, and then this has two, and that has three. So what you can do, and what I like to do, is to just go ahead and draw a line right after the one with the least number of decimal places. That's not lined up properly, I apologize. It'll look a little weird, but that way. Right, so the one with the one decimal place, I can just draw my line all the way up and down. And now it tells me really quickly how I need to round this final answer. Right, so in this case, I'm going to one place after the decimal point, 66.1. I look up my next digit, it's less than 5. So I'm going to keep that as it is. So this ends up being then 66.1. Right, so the final answer here can only have one decimal place. So the key difference for the addition subtraction is we look at the number of decimal places. The number that has the least number of decimal places tells us how many decimal places our final answer can have. Okay, so I mentioned to you that I like to do it this way. I like to line up the decimal points so I can see it, pretty quickly. You don't have to do it that way if you don't want to. I'm not going to force you to do it that way, but visually when I look at it, I can figure it out really quick. All right, and then if we look at subtraction, it's the same rule, right? So if we take 65.09, we subtract 3.0. We end up with 62.09, right? This has two decimal places, this has one decimal place. So my final answer then can only have one decimal place. So I need to round that to one decimal place, and what would that be? $62.1. Right, so we're rounding it to the first decimal place here. The 9 is more than 5, so we add 1 to the previous digit. So 62.1. All right, let's take a look at a couple, maybe at least one other example. So let's say I have 64.32 plus 9.1000 plus 105.9. Okay, so I want you to add those together and then report your answer to the right number of, or report your answer correctly according to the rules for sig figs. So your calculator gives you 179.32 or 3200. How many decimal places would you round this to? So this one here only has one decimal place, right? The others have more than one, so you can draw a line all the way down. We're going to round this to one decimal place, so this ends up being 179.3 as a final answer. All right, so the rules are different for multiplication, division versus addition and subtraction. It's important that you don't get them confused and you use the right rule for the right operation. All right, questions on sig figs and the rules for working with mathematical operations in sig figs.
On like the zeros with the decimal points,
Yes.
there's like, you have like 10.05. Would the 0 after the 1 count because it's in between the 1 after the decimal and the 1?
10.05?
Yeah, with the 0 after the 1 count since it's in between the 1, the 0 and the 1.
Would it count as a significant digit or significant figure? Yes. So this would have 4 sig figs, right? Because these here, they're both sandwich zeros. They are between non-zero digits. Yeah, definitely. Absolutely. Okay, other questions?